Hey guys, today's video is for academic chemistry, chapter 2, section 3, elements and compounds. For this video, you're going to need a periodic table handy. So your chemistry BFF, get ready to use that. All right, so let's start with talking about elements. An element is a pure substance, so that means it's all one thing, it's pure, and it can't be separated into simpler substances by physical or chemical means. So no matter what you do to an element, you can't break it down into anything else. And that's because it's made out of all identical atoms. So if you ever get a helium balloon, for example, inside it's all helium. So let's blow this up and look at the atomic level. It's a helium atom, a helium atom, a helium atom. And since you can't break down atoms, this is as simple as it possibly gets. Now notice all of these are by themselves, so each atom is just hanging out alone. It's not bonded to any other atom, and that's what makes it an element. Each element has a unique set of properties. So like chlorine is this green, it's a very toxic gas, versus gold is a solid and it's shiny and golden colored. Doesn't really bond with other things. Mercury is a metal. It's the only metal that is a liquid at room temperature. Bromine is a gas at room temperature. So yeah, all sorts of stuff. Um, all of your elements are listed on the periodic table. So if you're ever wondering, is something an element or not, you just look at the periodic table. And if it's there, it's an element. So like if I say carbon, oh, well, it's right here. So I know that it's an element. All names have a one or two letter symbol. The first letter is always capital and the second letter is always lowercase if there is a second letter. Sometimes if you have an older periodic table like down here, you might see some three letters. That's because those elements hadn't yet been identified. So they had three-letter unknown names given to them. So for example, if you see S and a capital C, that's saying sulfur and carbon, versus S with a lowercase c is scandium because the capital always says it's a new element. So, or cobalt would be another example, C and O. If the O is lowercase, it's cobalt, but if it was capital, then it would be carbon and oxygen for a CO. So let's talk about compounds. So atoms of elements combined with chemical bonds in a constant whole number ratio to form compounds. So like here is water. Water is H2O. So you can see H are those two little atoms and one O. So there's always whole numbers. You can't have half of an atom. And it's going to be consistent with that ratio. Water is always two hydrogens for every one oxygen. No matter how much water you have, it keeps that ratio. The subscript in a chemical formula tells you how many of each atom is present, and if you don't see a subscript, then the number is 1. So like how we had H2O, this is the H and another H, and here's your O or your oxygen. So you have two hydrogens and one oxygen. Ammonia is a cleaning substance that you might have seen. It's got one nitrogen. See how the N doesn't have a subscript, so it's got a 1. And then H3, 1, 2, 3 hydrogens. Now, all of these substances maintain that ratio. So for example, if I had a whole substance of carbon dioxide, it would look like this. It's still always two oxygens for every one carbon, and it continues looking exactly the same throughout. So this is a pure substance. Compounds are pure substances because all the way through it's exactly the same. It's just instead of one type of atom like you saw in the elements, you have multiple, but it's in chemical bonds together. So let's do some practicing of reading a chemical formula, and you're going to want your periodic table handy, ready to go. So sodium chloride is NaCl. Notice I know that this is sodium because it's a capital N and a lowercase a, so these two are linked. Chlorine, Cl. Sometimes that can be confusing. You might think it's an iodine. Just be careful. Generally, if it comes after a C, it's probably chlorine. So what is it made out of? All right. Well, the first thing is I have sodium, Na, so I have sodium, and then I have Cl, chlorine. And how many of each? Well, I don't see any subscripts, so I know I have one sodium and one chlorine. Let's do another one. How about calcium carbonate? So the elements present would be Ca is an element, C is an element, and O is an element. Because remember, we always start where there's a capital. So I know C and A are together as one type of element in that symbol because A is lowercase. This C is separate from this O because they're both capital. So let's go with the Ca. Look on your periodic table. Ca is calcium. There's no subscript, so I have one calcium atom. My capital C, if you look on your periodic table, you'll find carbon, and I don't have a subscript after it, so I have one carbon. Oxygen is O, and I have a 3, so this is also made of 3 oxygen atoms. Any sample of calcium carbonate will always have this ratio. If this ratio or set rate of calcium to carbon to oxygen changes, then it's no longer calcium carbonate. If you ever see parentheses outside a group of atoms, then that's saying you have that many of everything inside. So that number gets distributed in, and it gets distributed in only to the stuff inside the parentheses. The reason is you can imagine this as the parentheses is saying you have that many of those things, so you can also list it with everything inside the parentheses that many times. I'm going to show you how to do that with this example. So aluminum sulfate is Al2SO4 3. So this 3 means I have 3 SO4s. So sometimes it helps to think of it like this: Al2, SO4, SO4, SO4. So now I can clearly see my first element is aluminum, Al, and I have 2 of them. Sulfur, I have here, here, and here. Each of them are 1 because you look after. So notice how after the S, there's no number. So you assume 1. So I've got 1 here, 1 here, 1 here, totaling 3 sulfur atoms. The last element is this capital O, which we know to be oxygen. And if you forgot, it's on your periodic table. I've got 4, 4 more, and 4 more. 4 plus 4 plus 4 is 12. The other way you could have done that is distribute this 3 in. So 3 times 1 is 3. 3 times 4 is 12. Elements do not necessarily maintain their properties when they become part of a compound. So for example, silver oxide. So this is a sample of silver oxide, which might be surprising because when you think of silver, you think of something really shiny and silvery colored. When you think of oxygen, though, you think of a clear gas. It's something that you breathe. Notice neither of these elements maintained all their properties. So for example, it's still a solid like silver, but it didn't keep either of the colors. It's not silvery in color and it's not clear. Silver as a solid though would be kind of hard. You can hit it with a hammer and change its shape, versus this just crumples if you hit it with a hammer, silver oxide. So it really doesn't take the properties of silver or oxygen. It has brand new properties all its own as a compound. Another example is ammonia. Ammonia is made of NH3, or 1 nitrogen and 3 hydrogen. Nitrogen and hydrogen are both gases. They're around you right now. If you look around, they're in the air right here. You don't see anything. They're gases at room temperature and they're clear. They also don't have any smell. Like if you take a deep breath, you're not going to be like, "Ooh, smells like nitrogen." No, it doesn't have any kind of smell. But if you've ever cleaned with ammonia, you know it has a very strong smell. It's a liquid at room temperature. It is clear, but it's a clear liquid. So it has its own set of properties. It doesn't matter what elements make it up. You can't predict the properties of a compound based on what elements make it up. All right, have fun learning more about elements and compounds, and I'll see you in the next video.